Hello, it's Neha again, and welcome back to our NeetCode 150 journey. Today we are solving problem 4, group anagrams. If you are new to the concept of anagrams, or if you just need a refresher, I've explained it in detail in problem 2. You can find the video link in the description. The problem statement here is, given an array of strings, group all anagrams together into sublists. You may return the output in any order. So in this problem, we are taking the concept of basic anagrams a step further. Instead of comparing just two words, we'll group all words that are anagrams of each other together, and the order here doesn't matter. Let's look at what the problem expects from us before we dive in. So in the constraints, it says 1 less than equals string.length less than equals 1000. It simply means number of words should be between 1 and 1000. Each word has 0 to 100 characters, and all characters are lowercase English letters. Now let's talk about the efficiency. As for the recommendation, we'll have to aim for time complexity, big O(m) times n, and space complexity, big O(m), where m is the number of words and n is the max length of a word. So that means we need to avoid brute force pairwise comparisons or repeated sorting. Instead, there is an even better way that sticks to big O(m) times n. So the reason why we are not using brute force pairwise comparisons or repeated sorting, because sorting takes big O(n) log n time complexity, which is not suitable here. So here's an idea. Anagrams have the same characters in the same frequency. So if we convert each word into a frequency count of its letters, all anagrams will look the same. Let's convert our idea into Python code. I'll first initiate a dictionary named Anagram Map. You can name it as per your preference. So what we are doing here is we initialize a dictionary where the key will be a signature of the words. Basically, what makes the word unique in terms of character counts. And then we initiate a loop for each word in the array. And then we are setting up a list of 26 zeros. So basically we are initiating 26 arrays of zeros, one for each lowercase letter from A to Z. This list will help us count how many times each letter appears in the current word. Then we loop through each character of a word. So for char in word, count, so this is the main part here. In Python, every character has a unique ASCII value. So for A, let's say ASCII value is 97. And how we can get this? There is a built-in function, ord, O-R-D, which returns the ASCII value of each letter. So for example, if I run ord A, it's going to return 97. And for ord B, it will return 98, and so on and so forth. But here in our code, we want to convert each character to a position from 0 to 25, from A to Z, where A will be 0, B will be 1, C will be 2, and so on. So to achieve this, we simply subtract ord A from each character. So let me omit this and show you exactly what I mean. So, or char minus or a. So what we are doing here is, let's say our first character is C, letter C, and ASCII value of letter C will be 99. So 99 minus ASCII value of A equals, I'm getting 2, which is exactly what we need here. So what I'm going to do here is initiate a variable name index. So we are getting the position of char, each character of a word, and storing it in the index value, in the index variable. And then we'll increment count at the correct index, which will, which will update the right slot for that character. So count index plus equals 1. And then so here we need to convert this count variable into tuple, because right now this is a list and list cannot be used as dictionary. Therefore, we need to convert it into a tuple, and tuples are hashable and immutable, which is perfect for the dictionary keys. So I'll initiate a variable and convert this count into a tuple. And then we are going to check our edge case here. What if the key is not yet in the dictionary? What we are going to do here, if we run the code without using any edge cases, we are going to get the error. Therefore, to handle this, we'll have to create an empty list for it. So if key not in anagram map, we'll simply create an empty list. Anagram map key equals an empty list. And then what we are going to do here is, we are going to append the word to the list corresponding to the key. Anagram map key dot append word. And finally, return as a list of all dictionary values. Anagram map dot values. And here our code is ready. Let's run it and check if this works out. You can see the test cases are passed and it looks good. But Python has an interesting subclass of dictionary, defaultdict. It automatically creates an empty list for that key, for this one. So how we can use it? What we can do here is, instead of initiating a simple dictionary, we can use defaultdict. Defaultdict, it will be a list, and then simply comment out this. And if we run it again, it's still working. But this is more cleaner. Now we don't have to check if the key exists. Defaultdict automatically creates an empty list for us when needed. And this makes the code cleaner and easier to read. And it's perfect for this problem. Let's connect it back to the constraints and recommendation. Why did we even choose this approach? So, with up to 1,000 words and 100 characters each, a sorting-based approach would be like big O n times n log n, which is too large. For our frequency count method, it takes big O n times n. Because we loop through every word and every character only once, Also, the space complexity is big OM, as we store one group per word. So this approach is faster, scalable, and meets the exact recommendation. And that's our problem 4 solved. Done the clean and efficient way. We first wrote it using a regular dictionary, and then we improve it using default dictionary. And we picked this approach based on both performance and constraints in the problem. If you are enjoying this, keep going. Next up is top K frequent elements, and it's an interesting one. I'll see you in the next video. Bye-bye.